equals 1 minus x to the negative 3. And then I find the derivative of f, which is
Negative 3, 1 minus x to the negative 2.
so the question is it negative or is it not negative? It's positive, okay, because remember we take the derivative of the inside, which is negative, times negative 3 times 1 minus x to the negative 4. And so those two negatives cancel to get positive. So don't forget to take the derivative of the inside. Second derivative?
Negative 12. 1 minus x to the negative 5.
You just forgot to take the derivative of the inside, right?
Why do I always okay,
So don't forget to take the derivative of the inside. So we have negative 4 times negative 1, okay, which is just 4 times 3 times 1 minus x and negative 5. Sorry?
6.
So the third derivative? Oh yeah, so we don't want to simplify and multiply through. Okay, we just want to leave it like this and you'll see why in a second, but it's just easier to find the pattern this way. Oh, is that what you were mumbling under your breath? Why am I not multiplying through?
No, I said maybe we'll get it right this time.
Oh, okay. Yeah, let's try it. What's the third derivative?
5 times 3 times 5.
Right, positive, right, because the two negatives cancel. So we have 5 times 4 times 3. You do you? Times 1 minus x to the negative 6. Right, so eventually, again, we want to find a pattern, and so it's easier to find the pattern sometimes if we don't multiply through, if we just leave it unsimplified.
Wait, so do you pretty much find like as many derivatives until you find a pattern and then you're just like, oh, okay, like move on?
Yeah, so again, usually up to the third derivative is okay. Sometimes you have to go more than that, though. Okay, so you really just have to use your own judgment of how many you need in order to find the pattern. Okay? But don't do less than 3. It's not really safe. Okay? So now we evaluate at the center, which is x equals 0. So f of 0, I plug in, and I have 1 minus 0. So 1 raised to the negative 3, which is just 1. Okay, so f prime of 0, now I plug in. Again, 1 to the negative 4 is just 1. So now I'm just left with 3. Okay, f double prime, I have 4 times 3 times 1. So I just have 4 times 3. Again, don't multiply through. And the last one, I have 5 times 4 times 3, okay, times 1. Okay, and so now, okay, as the summary page says, sometimes we want to switch steps 3 and 4 because sometimes it's easier to find the pattern before we plug in. So switch steps 3 and 4 because sometimes it's easier to find pattern before plugging in. Anyone want to give it a shot? Yeah.
There's an n plus 1 for third.
N plus 1 for, okay. What else? Oh wait, n plus 1. Why n plus 1?
get to the second derivative. You get n, so it's the third term, so 3 plus 1 is 4. Oh, no, yeah, that's wrong. That's wrong.
Do you want to try again, or
Yeah,
you don't want to try again?
N minus.
N minus 1. Why n minus 1?
Because you start off, there's like no factors, I guess you just start with negative. But, like, it starts being like a factorial label.
Okay, so let's take a look at this one. Here n equals 3 because we have the third derivative, okay? And here we have 5 times 4 times 3, and then it just stops. We don't multiply by 2 by 1, okay? So here we're increasing by 2. So we can think of this as 5 factorial, but then we're divided by 2. Okay, so 5 factorial divided by 2 is the same thing as this. Because this is 5 times 4 times 3 times 2 times 1, but we get rid of the 2 times 1, we just have 5 times 4 times 3. Uh-huh.
Can I take a shot at it?
Oh, yeah.
Is it 2n minus 1 divided by 2?
Why 2n minus 1?
Never mind.
So let's figure out the rest here first, and then maybe it'll make more sense. Here, we can do the same thing. We have 4 factorial, but we don't have the 2 times 1, so we could just divide by 2. Okay? Here, we have 3 factorial, but again, we don't have the 2 times 1, so we divide by 2. And here, we have 2 factorial divided by 2, because that's just 1. Does that make sense so far?
Can you just explain why we divide by 2? Just because.
Yeah, because it's starting to be a factorial, but then it stops, right? So we have 5 times 4 times 3, but then we leave out the times 2 times 1. So if we're going to write this as a factorial, we need to divide by 2. Because 5 factorial is 5 times 4 times 3 times 2 times 1. So we're just getting rid of the rest of it, and so this equals this. Right? If I brought this 2 to the other side, that would equal 5 factorial. Does that make sense? Does everyone understand this part? Okay, so then now we want to find the pattern. And so we have the n derivative, that means the n derivative at 0. And what is the pattern? Okay, good. N plus 2 factorial over 2. Right? Because here, if n equals 3, we need to add 2 to get to 5 factorial. Same thing with n equals 2, we add 2 to get to 4 factorial. And all of them are divided by 2. Does that make sense? Okay. So then the last step, okay, so if I'm going to find the pattern first, then I use a different formula. I just express it as a general summation here. So I have the n derivative of 0, okay? My center is 0, so I have times x over n factorial. So that's just the general form instead of writing out term by term. So if I find the pattern first, I use this formula. And then I just plug in. So I get the sum from n equals 0 to infinity of n plus 2 factorial over 2 times n factorial times x to the n. Oh, sorry, that should be x to the n. What is n plus 2 factorial equal to? N plus 2 times n plus 1 times n factorial, and now I can cancel those 2 out. So now I'm left with n plus 2 times n plus 1 over 2 times x to the n. Fun stuff, right? What? Oh, yeah. Any questions? Yeah.
Okay, so can you find the pattern beforehand, like every time, and then kind of plug it in to make it easier?
No, because it won't, so you have to use your own judgment here. Sometimes you can find the pattern immediately, sometimes you can't. And if you go back to the sign example, you can't find the pattern immediately, so you have to plug in first. Okay? So use your own judgment of what would be good.